So we will go into the chapter actually, mixture, the next chapter, mixtures, solutions, and solvents. What is mean by mixture? Mixture is nothing but you will have two or three or many different substances. Like I don't know how many of you are aware. Like there is a food item. Like whatever the food item you take, for example, let it be, there is a food item actually chips, certain chips items actually it will have more than one components, so that is a mixture. So I will show you actually one mixture actually exactly. See, then you will have a better idea. This is nothing but a salt. Okay, so if I open the salt and if I put that salt into this, okay, if I put this salt into this particular bottle, okay, so now this contain only sodium chloride, and in the next bottle, suppose yeah in the next bottle, okay, I will take this is nothing but a sugar. So this is salt, this is sugar. Now this particular bottle contain only one substance, right? So this contain one more substance, so I will just take it and I will add it. Okay, so now this contain two substances actually. One is salt and next one is okay, next one is actually sugar. So you can see just by external look, you don't have a two different substances, right? So you know, like it both look similar. One is salt also, one is sugar also. So this is nothing but a mixture, because actually both are not mixing very properly. Like it is not combining, it's not chemical undergoing any reaction, but it is just a mixture, right? Okay, so this is an example of mixture. Okay, now let's see what is mean by solution. See, solution, it contain like you can see many solutions in and around us. See, for example, the this thing, I mean, like lemon water, or like sometimes mostly the solutions, it will contain two or sometimes three components. You know, if solutions contain two components, we call it as a binary solutions. BINARY, binary solutions. For example, use this is water, okay, and if you put some sugar, yeah. So here actually this see the sugar, it is nothing but a solute in this. So the here actually I dissolve this. This is a yeah. This water, it contain two components, right? Actually, this solution. So the solution contain two components. One is water. Next one is solute. Okay. Next one is solute. So here the sugar, it is the solute, and water, it is a solvent. See now, yeah, we will just mix it. Yeah, we will mix it actually properly, so that you know this sugar, it will properly dissolve into that. Okay. Of course, actually, yeah, sugar, not only sugar, you know, you can use any solute. It could be sodium chloride, and yeah, it could be anything. And one thing, you know, you should know actually, like, you know, yeah, actually here I added a more amount of solute, right? More amount of salt, more amount of sugar. So when after I dissolve it for a long time also, it is not getting, it is not getting solvated. Okay, you should know one thing, that this solution, it is called a saturated solution, because no more sugar you can add into this. The maximum amount of sugar you can add into this is, it is over. So if sometimes no, even if you add some sugar, there will be still more amount you can dissolve. More amount of sugar you can dissolve. Such solutions are called unsaturated solution. In this case, it is a saturated solution, because even if you stir it also, you can see still there is some more, you know, you can see there is still some more particles are there. So this is a saturated solution. Are you clear? So there are solutions actually, you know, like not only sodium chloride, sorry, sugar. You can put a sodium chloride, you can put magnesium nitrate or calcium chloride, or you know, silver nitrate, silver chloride. But only one thing, not all solutes will be that much dissolvable, and which we will see that next. Okay, so a solution contains two components, either two components, solvent and solute. In this thing, water is the solvent, Sugar is the solute.
Hi. You already saw how is the solubility of a sodium chloride and sugar, right? Actually, how it is in the water. But at the same time, you should not think that all the solutes it will dissolve in the water that much. Suppose if you are putting, say, potassium hydroxide, say this is potassium hydroxide, right? Actually, potassium hydroxide, this will dissolve very nicely in the water, more than sodium hydroxide. And at the same time, copper sulfate, that also will dissolve in the water. But there are certain solutes which doesn't dissolve that much. Actually, each solute has different dissolution rate. Say, for example, in your in your textbook they are referring the calcium carbonate. Instead of, since calcium carbonate at the present not available in the lab, I am taking silica gel. Okay, silica gel. So you can see I will just add some pretty good amount of silica gel. So you can say, yeah, I will add it. See, okay. So if I try to dissolve it, let's see what will happen. So you may feel like it will dissolve, okay. But on the other hand, silica gel also, it doesn't dissolve as much as, like this sugar, or like say this is almost 100 ml of water. If I put more amount, okay, this is not going to get dissolved. Actually, I'm sure this is not going to get dissolved as much as uh, sodium chloride or a similar kind of salts. So which we can see very evidently. For instance, like yeah, I will take this is measure funnel. Okay, so yeah, I will do one thing. I will pour through here. Yeah, okay. Instead of that, okay, I will use the speaker. So major. See, you can see when it is just after steering. Okay, one more time. I can see. Let it. I will steer it. Sorry, through this end. I will steer it. Still, this silica gel is not going to dissolve. You can see now it look like it is very nicely dissolved when I am steering. Okay, so but I just took it. Now you see with just within very short amount of time, within very short period of time, so all this silica gel which was dissolved, it is getting settled. So now, so like if I pour this silica gel here, okay, remaining and all it will go, but see, it's getting settled. There is no silica gel, is almost no silica gel, it got dissolved. So there are different solutes, it got a different dissolution rate. For instance, you can see this one, silver nitrate. See, silver nitrate, it got in 100 ml of water, it will dissolve almost 241.3 gram. On the other hand, calcium nitrate, so it will dissolve 102.1 gram. Sugar, the one which we dissolved so previously, it will dissolve around 91 gram in 100 ml. Potassium nitrate, it will dissolve 37.9 gram. Potassium sulfate 12 gram. Calcium hydroxide 0.113 gram. See, 0.113, that means even calcium carbonate 0.0013 gram, silver chloride 0.002 gram. So that much less is the dissolution rate of, okay, these solutes. Okay, so just because the sugar was dissolving very nicely doesn't mean that all the solutes it will dissolve. For example, calcium hydroxide and calcium carbonate and silver chloride, the last three salts. Okay, so its dissolution rate is even less than 1 gram. That means it is very sparingly soluble. Okay, sparingly soluble, or it is very less soluble actually. We call it as a sparingly soluble. Achha. So this is something you should know. Actually, the solutes, whether it is dissolving in water or not, it purely matters of the nature of the solute. Certain solutes it will dissolve nicely, certain solutes it doesn't. Okay. So, let's see how we can help a solute to dissolve in a solvent. See, this is one of the this is a water containing one of the salt
let it be copper sulfate, or let it be anything actually, like yeah, cobalt nitrate. Okay, so you can see the cobalt nitrate particles, it is getting, like we put some cobalt nitrate into it, and after some time it is getting settled in the bottom. Let's see how we can dissolve it more. So, in order to make it more dissolvable, actually, the best thing, on easiest way, what we can do is we can uh, put a steering rod and we can steer it properly. So, more and more amount of salts or like a solids, it will get dissolved. Okay, so this is of course the commonmost thing what we do. Yeah, another thing is, you can, next idea is you can best you can heat it. Once you heat it, actually more amount of particles, no, actually more and more amount of particles to get dissolved, because the heating will make the particles to acquire more energy. Actually, more kinetic energy will be acquired. So, like the movement of particles will be faster. So ultimately, actually, like more than steering, if you heat it, the amount of particles it get dissolved in a solution, it is higher than uh, much higher than you know just your steering. More amount of solutes it get dissolved, and which is evident from the green color actually, green color. Okay. Now, already we have seen how is the solubility of water and what kind of salts it is getting dissolved in water, right? But you see the people actually, like who is your close friend. See, just because one person is your close friend doesn't mean that all people will be singing with your mood, and all the people they will be singing with your interest, right? So, that is something which you should know. The same way it is applicable to water also. See, certain salts, like say, for example, sodium nitrate, sodium chloride, or like, if we are technically speaking, it's ionic salts. Ionic salts, actually, it is, those ionic salts like sodium nitrate, sodium chloride, and potassium nitrate, these kind of things, it will get dissolved in water. Okay, but on the other hand, this wax, and for example, like say, for example, like nail polish and wax, paraffin wax, if you dissolve into water, it doesn't dissolve. It will remain as undissolved form. So, not all solutes it is getting dissolved in water. For example, like see this the there is a certain powder or like a certain tablets actually which uses to kill cockroach. So that is not going to, if you dissolve it into water, it won't dissolve. If you put some that cockroach killing tablets, if you dissolve it into water, it is not going to get dissolved. Okay, so that is something you have to know. Like polar substances, usually polar substances, it get dissolved in water, but non-polar substances like a paraffin wax and all those things, it's not going to get dissolved. Okay, so and suppose like and there are not just water, any liquid, and say like ethanol, acetone, hexane, cyclohexane, and toluene, and any liquid, let it be polar liquid or kerosene, any liquid, you can consider it as a solvent. So only thing is, what solute it dissolves into, that matters. Certain ionic solute it dissolves into water, but a non-ionic solutes, say like non-polar solutes, it is not getting dissolved into water. Okay, so toluene, it is like non-polar substances, it never get dissolved into water. Okay, so and there are the nature of solvents also, it varies. For example, like if you pour water outside, it will take some time to evaporize. On the other hand, if you pour some this propanol or ethanol on your surface of skin, it get evaporized and your skin get cold. Your skin, it get cold. Okay, so those kind of solvents actually which get evaporates very immediately, we call it as a volatile solvents. Okay. So in this page number 17, explain. I will write the questions also in words. Explain each term in your own words: soluble, insoluble, and aqueous solution. Okay, we shall see what is meant by soluble. Soluble means, like say, you take any beaker which containing water. So NaNO3. Okay. So NaNO3, if you put it into water, this sodium nitrate is going to be soluble because it is soluble. Okay. Insoluble means like what to say. Suppose if you are putting in the same water, you are putting paraffin. Okay. So this paraffin is not going to be soluble. So paraffin is insoluble. And what is meant by aqueous solution? Aqueous solution, see a solution containing water. Water as the solvent, that is called aqueous solution. For example, like you take water, you are putting sugar or NaC, sodium chloride. So this solution is going to be aqueous solution because the solvent in this case it is water. So any solution containing water as the solvent is called aqueous solution. Okay. So next question is look at the table on page 16. Which substance in it is most soluble? Okay. So yeah, page 16. So I will redraw the things here. So it is silver nitrate. So that is going to be 241 gram, and calcium nitrate. Calcium nitrate is going to be 102. Sugar or glucose, it is going to be 91. Potassium nitrate, it's going to be 37.9. Potassium sulfate, it's going to be 12. Okay. And calcium hydroxide, this is going to be 0.113 gram in 100 ml of water. Silver chloride. Okay. So yeah, the question is actually this is the table. Which substance in it is most soluble? Obviously silver nitrate, right? So if you take 100 ml of water, 241 gram of silver nitrate is going to be soluble. Even this knowledge is new for me too, because I thought silver nitrate is usually silver salt, so that is not that much soluble. So I was having the expectation that even silver nitrate also will have the same tendency, but it is on the other hand, it is otherwise. So about how many times more soluble is this substance than potassium sulfate at 25 degrees Celsius. So potassium sulfate, where is it? Yeah. So 12. So if we are comparing this 241 divided by 12, how much you can get? So yeah, 20. More than 20 times. Or more than 20 times it is going to be more soluble than potassium sulfate. I have done a rough calculation. So, and the substance in A gives colorless solution. That means if you what they are telling is, yeah, I will draw here. If you take AgNO3, it gives a colorless solution. Okay, so AgNO3 gives a colorless solution. So what they are asking is, what will you see if you add 300 gram of it? Suppose you are adding 300 gram of silver nitrate into 100 gram of water at 25 degrees Celsius. What will happen? See, its maximum capacity at 25 degrees Celsius is 241, right? So if you are adding 300 gram, some amount, it won't dissolve actually. 241 gram out of 300, 241 gram will dissolve, remaining 59, 59 gram will remain. Okay, so that is going to happen actually. That solution, the entire amount will not dissolve. So, and now they are asking actually, suppose in this 300 gram water, what will happen if you are going to heat it? Obviously, when you heat it, most of the time what will happen is actually this solute, it excess 59 gram or so, it will undergo, it will dissolve. Okay, now the third question. Now turn to the table at the top of page 160. Name two metals that have no insoluble salts. Okay. So yeah, I don't need to. I don't want to go into that page 160. I can tell you from the periodic table. So it is a sodium and potassium. These salts actually. So sodium and potassium. That it's most of the salts. It is going to be soluble in water. Sodium nitrite, sodium chloride, or sodium sulfate, or sodium fluoride. Sodium fluoride solubility will be little bit less, but that is also still soluble. Sodium nitrite, sodium chloride, sodium fluoride, or sodium, uh, you know, uh, sodium chloride, or any soluble. Same way, potassium nitrite also, potassium chloride, potassium hydroxide, and potassium oxide. Any sort of these two metals, it is going to be soluble. It is going to have complete solubility. Name one other group of salts that are always soluble. Still again, like yeah, let me repeat. Name two salts, two metals that have no insoluble salts. Yeah, actually this is the one. And the next question is, name one other group of salts. I mean other group of salts that are also always soluble. Again, like if you see to yeah, if I go into that, then actually instead of not calcium, yeah, like helium, magnesium, calcium, strontium, actually strontium and barium. These two also, it is going to be always soluble actually. Okay. See if you can give three examples of solids you dissolve in water at your home. Yeah, at your home, what are the common salts we dissolve? Let it be sodium chloride, sugar, plus yeah, which one? Maybe like carbonate, like sodium bicarbonate, NaHCO3. Okay, so these are some of the common salts. And insoluble salts you use at home. Commonly, what are the insoluble salts? See this, the one which he uses in for killing the cockroach, and yeah, that is a common example. And yeah, and now next is question: name two solvents other than water that are used in the song. What are they used for? So what are the two solvents actually? One is, you can write, one is corrosion. Corrosion. Okay. And the next one is, like you can say it is spirit. Okay. Yeah. Name. Sorry, I didn't complete it actually. Name two solvents other than water that are used in the home, what are they used for? Corrosion for what purpose actually? Like sometimes for removing the stain also we use this corrosion. Spirit also sometimes for removing the nail polish, or like sometimes dissolving some of the common steps we use as a spirit. Okay, now next question. Many gases are dissolved in water. Try to give some examples. Yeah, like see this rainwater. See, I will tell you the rainwater. Rainwater actually is it dissolves a lot of gases. For example, it dissolves carbon dioxide also. Water actually it dissolves carbon dioxide and yeah, HCl. HCl actually it is a gas. Once you dissolve into water, actually this will go HCl aqueous. Actually, we commonly call it as a hydrochloric acid. Carbon dioxide also, mostly these gases it dissolves in water. Carbon dioxide it dissolves in water. It forms carbonic acid.